In this video, we're going to talk about the foundations of geometry. Okay, so let's start off with a point. The reason why we start off with a point is because any geometric figure is a set of points. Okay, so what is a point? First off, it has no size. You can think of it as a location. It's represented by a small dot, and it's named with a capital letter. So here's a couple of examples of two representations of points. So we've got a small dot, we've got a capital letter, A and B. So here's point A, here's point B, and we can name it point A, or sometimes we'll just call it A. Space is the set of all points. All right, next up, a line. A line is a series of points that extends in two opposite directions without end. You can name a line with any 2 points on that line or with a single lowercase letter. Okay, for example, we've got a diagram here. We've got point A, point B, and point C all on the same line. Point D is not on the line, it's up here. So there's several different ways that we can name this one line. We can name it AB. So notice we picked 2 points from that line and we put a little line symbol on top. And notice it's got 2 arrows on the end. Or we can flip them. We can name it BA. The order doesn't matter when we're naming a line. Okay, we could also pick 2 other points, B and C, or we can name it CB. Or the other pair that we haven't picked yet is AC, or flip it around, CA. Okay, we can also use this lowercase letter. Whenever you see that lowercase letter on the end of a line near the arrowhead, we can name it using that lowercase letter. In this case, letter T. Okay, collinear is points that lie on the same line. So, for example, A, B, and C in this diagram are collinear. If we have collinear, we've also got non-collinear. So non-collinear are points that do not lie on the same line. For example, A, B, and D are non-collinear. There's no way we can draw a straight line through points A, B, and D. Next up, plane. A plane is a flat surface that has no thickness. The way that we draw planes on paper, we have a parallelogram here. Notice we've got some points that are on that plane. Point J over here is not on the plane. And we've got this capital letter up here in the corner. Okay, we name a plane with a single capital letter or with at least 3 of its non-collinear points. So for this plane, we could call it point P. Notice this P doesn't have a point associated with it. It's tucked up in the corner. So we can name it just with that point, with that name P. Or we could pick any of these 3 points that are on the plane that are not in a straight line, that are non-collinear. So we could name it plane F, G, H. Coplanar are points and lines in the same plane. An example would be points E, F, G, and H, as we've already stated. They are on the same plane. They're on plane P. They are coplanar. If we've got coplanar, we've also got non-coplanar. Non-coplanar points are points and lines that are not in the same plane. So an example in this diagram would be E, F, G, and J, where E, F, and G are on plane P, but J is out here in space, not on plane P. Okay, and it's important to note that points, lines, and planes are undefined terms of geometry. Okay, next up, we've got a postulate. A postulate is an accepted statement of fact. Okay, you can also interchange the word postulate with the word axiom. They both mean the same thing. So an accepted statement of fact. Our world of geometry is based on a certain number of postulates or axioms. Okay, one of those, postulate 1-1 we'll call it, says through any 2 points there is exactly one line. Okay, another way to say that is that any 2 points in space are collinear. Okay, our example here, we've got 2 points A and B. Line T is the only line that passes through points A and B. You can call it line AB, or you can call it line T, but it's the same line. So there's exactly one line that goes through points A and B. Postulate 1-2 says that if 2 lines intersect, then they intersect in exactly 1 point. Okay, in our diagram again, point B is the intersection of line T and line V. Okay, postulate 1-3. If 2 planes intersect, then they intersect in a line. Interesting. So we've got 2 planes here, plane P in green, plane Q is in purple. Okay, notice the somewhat three-dimensional effect where plane Q is kind of going into the board and to the left. Plane P is going into the board and to the right. Their intersection is all along this line in black here, line T. Okay, so anytime 2 planes intersect, they intersect in a single line. Okay, one more postulate, 1-4. Through any 3 non-collinear points, there is exactly 1 plane. Okay, let's look at some examples. We've got our figure here. We've got a rectangular prism. Example 1 says are points A and C collinear. So we've got point A and point C. Yes, they are collinear. Even though there's not a line drawn in our diagram, remember through any 2 points, there's exactly 1 line. Any 2 points are collinear. Okay, so on a diagram, it's not necessary for a line or a plane to be drawn in order for it to exist. Okay, number 2, are points B, C, and H collinear? So we've got B, C, and H. No, they're not collinear. While they may somewhat look collinear on the board or on the paper, again, think about we've got a 3-dimensional figure here, our prism. Points B and C are up here on the top right, but point H is down here at the bottom left. So we could not draw a straight line between those 3 points in space. Okay, number 3, are points A, E, H, and D coplanar? Okay, so let's identify our points A, E, H, and D. Yes, they are coplanar. So they make up this left side of our box here. Number 4, are points E, F, G, and H coplanar? So E, F, G, and H are our points. No, excuse me, E, F, G, and C. E, F, G, and C. Okay, E, F, and G are all on the bottom, but C is up here on the top. So no, they're not coplanar. There's no way that a single flat surface would be able to encompass all 4 of those points. Okay, number 5, are points A and G collinear? A and G. Yes, again, any 2 points in space are collinear. So yes, so if you imagine a line connecting the back top left corner of this box to the front bottom right corner of this box, okay, going through the middle of that box. So yes. Number 6, last one, are points E, H, B, and C coplanar? We've got E, H, B, and C. Yes, they are coplanar. If you can visualize, imagine a piece of cardboard or some kind of a flat plane going diagonally through that box from the top right to the bottom left. Yes, they are coplanar.